Scientific notation. So we are still talking about our powers, but we're going to move into using our powers to write numbers that have a lot of digits to them. So you've seen scientific notation before in your science classes, and using it to write numbers that are really long to write. Either they're representing a number that is really small, so you're looking at something under a microscope perhaps, or you're measuring something that is really big. Perhaps we're talking about the distance of planets from each other. And instead of writing out all those digits, we can use scientific notation to help us write those numbers a little more efficiently, and also be able to compare them a little more efficiently. So let's take a look at what scientific notation looks like. So scientific notation, a number is written in scientific notation when it is represented as the product of a factor and a power of 10. So we're going to have two things that we're multiplying together. It's product. The factor must be greater than or equal to 1 and less than 10. So let's take a look at a number in scientific notation. 8 3/10 times 10 to the negative 7th power. So you'll notice that the factor in front here is between 1 and 10. So it can be 1, but it can't be 10. So I need to have a digit in the ones column and nothing to the left of it. That's it. But I have to have a digit in the ones column. And then I need a power of 10 that has an integer exponent. So we're not going to work with any fraction exponents here. We're going to have a nice integer. It can be a negative or it can be a positive, but we're going to write it as a power of 10. So I know we've been working with our negative exponents and writing them so that they're positive, but we're leaving it as either a positive or a negative exponent with a base of 10 here. So we're not writing it as a fraction. All right, so we're going to take each number and we're going to see if it's written in scientific notation, and we're going to explain why or why not. So our first number, 12 times 10 to the 4th power. So this looks very much like scientific notation. I've got a number, I've got a multiplication symbol, I've got a power of 10. However, this 12 is not between 1 and 10. So no, this is not scientific notation because 12 is not between 1 and 10. So we have the power of 10, but it's that 12 that's throwing things off. It looks it, but it's not exactly. And our second one, 3.24 times 10 to the negative 3rd. Again, this looks very much like scientific notation. I have a power of 10 here with an integer exponent. I'm multiplying. Is this number between 1 and 10? Yes, it has a digit in the ones column. It doesn't have anything bigger than that. And it doesn't have a 0 in the ones column. So yes, this is, because 3.24 is between 1 and 10. And it is multiplied by a power of 10. So again, this is what our scientific notation looks like. You've seen that before. That should be pretty familiar. All right, let's take those numbers that are in scientific notation and write them in standard form. So standard form, how we're used to seeing a number. We're not writing it as a product of a power of 10. We're going to start with our exponent. The exponent indicates the number of places to move the decimal point. So the exponent on that power of 10 is going to tell you how many places you're going to move the decimal point around. If the exponent is negative, move the decimal to the left to make a number less than 1. So that negative exponent, and if you think about what that negative exponent means, that means I'm really dividing by a power of 10. So I'm getting a number that's smaller than 1, and if I multiply by a number smaller than 1, I'm going to end up with a number that's smaller than 1. So we're going to end up, if I have a negative exponent, I'm going to end up with a smaller number than 1. If the exponent is positive, move the decimal to the right to make a number that's greater than 1. So our positive exponents tell us that in standard form the number is larger than 1. Our negative exponents tell us that in standard form our number is going to be smaller than 1. So let's see how this works. We're going to write the number in standard form. So we have 6 times 10 to the 7th. So this positive 7 here tells me that this was a number that's measuring something bigger. I'm going to have a number that's bigger than 1. So I'm going to start with my 6, and my 6, we don't write the decimal point typically, but it's just to the right of the 6, so I'm going to start by writing 6 with a decimal point there. And then I'm going to move the decimal 7 places, so 1, 2, 3, 4, 5, 6, 7. So I moved it over 7 places, and then I need to fill in those spaces with zeros. We're not adding zeros, because if I do 6 plus 0, that's just 6. They're using them as placeholders here, so I'm holding the place in each of these parts of my number here. So I need to fill in this case, 7 zeros. It's not always the case that I'll have to fill in 7 zeros, but it is the case in this particular instance. So then when I rewrite this as my final number, I end up with 60 million. So 6 with 7 zeros after it. Let's take a look at another one. Now this one has a negative exponent to the negative fifth power, so 9.9 times 10 to the negative fifth power. So since this is a negative power, I know my original number, my number in standard form, is something small. It's going to be something less than 1. So I know I'm going to move my decimal to the left. So I start with my decimal in between the 9 and the 9. And I'm going to move it to the left 5 places. So 1, 2, 3, 4, 5. So move 5 places to the left. And I need to put 4 zeros in there as placeholders to hold each of those places, my 1s, my 10s, my tenths as I go smaller. When I rewrite it, I end up with 0.000099. So this is a number that's significantly smaller than 1. So that negative exponent, I'm ending up with a number that's less than 1. And my last one here, 1.285 times 10 to the fourth power. Again, this fourth power tells me this number should be larger than 1 in standard form. So I'm going to start with my decimal that's in between the 1 and the 2. I'm going to move it 4 places to the right. So 1, 2, 3, 4. Notice I only have to put 1 0 in here to hold a place. So I end up with 12,850. So we should be able to take a number in standard form, recognize that it's in standard form, and then also be able to write it, recognize that it's in scientific notation by a number between 1 and 10 and multiplied by a power of 10. I should also be able to take a number in scientific notation and change it into standard form.